Hello student, my name is Devendra Singh. I am teaching you elementary quantum mechanics in BSc third years, Eigen value and Eigen functions. Wave functions इनको बोलते हैं. Eigen value and Eigen functions, wave functions. For a stationary or standing waves in a stretch string, the amplitude function fx can have significance only for certain definite value of lambda. These functions will be those which must satisfy the following condition. Number first, fx must be equal to 0 at each end of the string, as the string is fixed at these points and the amplitude of the vibration is 0. Number 2, fx must be single wave and the finite at every point on the vibrating string. The amplitude has a definite value at any given instant. On page number first. On page number 2, similarly, Schrodinger wave equation, being a second order differential equation, can have number of solution for the amplitude function phi, but only those values of phi are acceptable and have significance which correspond to some definite values of the total energy E. Full stop. Such values of the total energy E is called Eigen values. Full stop. These values are also called proper values or characteristics values. Full stop. The corresponding values of the function phi are called Eigen function or wave functions. In the case of the stretch string, the Eigen function of the Schrodinger equation will be those which satisfy the following condition. Number first, psi must be single valued and the finite, that is, for each value of the variable x, y, z, there is only one definite value of the function psi. On page number 2. On page number 3, number second, psi must be continuous, that is, there must not exist any sudden change in psi as its variable are changed. Number third, psi must become 0 at infinity. We define a class of functions as all those functions which obey certain specified conditions. It may happen that in a given class there are functions which, when operated on by an operator, alpha, are merely multiplied by some constant a, or in symbols alpha fx is equal to a fx. Those members of the class which obey such a relation are known as characteristics or eigenfunctions of the operator alpha. The various possible values of a are called the characteristics values or eigenvalues of the operator. On page number 3. On page number 4, for example, when function psi is equal to sin x, on which the operator alpha, first of the various possible values of a are called the characteristics values or eigenvalues of the operator. First of, for example, when function psi is equal to sin kx, on which the operator delta is equal to d by dx operator, we get d psi upon dx is equal to d by dx sin kx is equal to k cos x, k cos kx. Since k cos kx is not psi, so d by dx is not an Eigen operator for the function psi is equal to sin kx. Now let us consider d square upon dx square as the operator for the same function psi is equal to sin kx. Then upon operating we get d square psi upon dx square equal to d by dx equal to d upon dx sin kx is equal to d by dx is equal to k cos x आ जाएगा is equal to minus k square sin kx is equal to minus k square psi. On page number 5, here d square upon dx square is an Eigen operator for psi is equal to sin kx. Thus, psi is equal to sin kx is an Eigen function for operator d upon dx square having Eigen value minus k square. Full stop. Let us take another function when function psi is equal to EImx, operators are d by dx and d square upon dx square. Then d by dx psi is equal to Imx, इसमें पावर में लीजिएगा, is equal to d psi upon dx is equal to Im psi. Here d upon dx is an Eigen operator, Im is the Eigen value for the Eigen function psi is equal to Eimx. Also d square psi upon dx square is equal to Im e की पावर Imx. D square psi upon dx square is equal to minus m square psi. Here d square upon dx square is an Eigen operator with Eigen values minus m square for Eigen function psi is equal to e की पावर Imx. As is clear, different Eigen operators have on page number 5 different Eigen values for the same function. The